So hello and welcome from our side as well. If you ever wondered how to quickly create and deploy streaming applications, this session is for you, right? So we're going to show you how we can interactively query streaming data from a fully managed notebook environment, how we can productionize streaming applications, and we are also going to take a look under the covers how the service operates and provides the resources you're using when you're actually running queries against your stream. So my name is Stefan. I'm a streaming architect from the Kinesis team, and I'm going to lead the first part of this interactive session. So I'm going to run through a demo so that everyone gets to see what the service is all about. And then I'll hand over to Danny, who is an engineer from the Kinesis team, who will then talk about more the technical details of the service and some more technical aspects. We would like this to be an interactive session, so feel free at any point to shout out if you have any questions. Feel free to interrupt. And we we don't have too many slides, so that you can really see what the service is like and then get a feeling for how we operate it. Cool. So with that, I'm going to start sharing my screen and run through a little demo on how you can interactively query streaming data on AWS. So I hope the font on the screen is big enough. I can make it bigger if people shout out, but unless someone protests, I'll keep it as is. And what you see right now is the AWS Management Console. So the service we're going to use is called Kinesis Data Analytics Studio, and it really is a managed notebook experience for running streaming queries. You start off with creating a notebook, but to save some time, I've already done that. But essentially, to create a notebook, you specify the resources that are going to be used for the underlying Flink cluster. You specify network connectivity. So we are going to read from Kafka. You can establish network connectivity so that the notebook can actually connect to your Kafka cluster. And you can also associate permissions to the notebook so that the notebook and the Flink application can sign requests against other AWS services. So with that, I'll open the notebook. So this has already been running. It takes 1 to 2 minutes to spin up. And I can connect to the notebook, which is basically Apache Zeppelin, an Apache Zeppelin managed notebook. And with that, I'll start creating a node. So I'll call this Flink forward. And I can start querying my stream. But before we get into the details, I'd like to show you what this looks like, what I'm going to show you. Unless, sorry. Oh, this is fantastic. So let me refresh the screen and then hopefully Zeppelin recovers. No, it does not. So apologies. Maybe Danny, you start with your part of the demo. That's off for a great start. Sorry, apologies.
Yeah, I'll take over then and let Stefan fix his in the background. So I'm going to start off by explaining the use cases of Kinesis Data Analytics Studio and our other offering, Kinesis Data Analytics for Apache Flink. So let's start with Studio. So with Studio, we are targeting rapid prototyping in an interactive development environment. This will allow you to gain quick insights into your data, and we'll promote our queries to production when we're ready. We're targeting higher level SQL abstractions while retaining support for Python and Scala. And Studio is typically run during office hours because it's a development environment. So a developer may get to the office, run up their notebook, and then at the end of the day, they can turn it off. So comparing that to Apache Flink offering, we're targeting highly available Flink jobs running production workloads. So these workloads are running indefinitely, and we're targeting the languages we're targeting are more Java or JVM languages and Python at lower abstractions, such as a data stream API and also table API. In terms of the lifecycle differences between the two offerings, they both use the exact same APIs. So if you're familiar with AWS SDK or AWS CLI, the Kinesis Analytics service offers endpoints such as create applications, start applications, stop, update, etc. And we'll reuse the same endpoints for Studio versus Apache Flink, but they have slightly different semantics. For example, if you were to stop and start a Flink job, the service will take a save point and then restore your job from the save point to allow the job to continue where it left off. Whereas with Studio, because it's a development environment, we will not capture any state. If you have running jobs, when you stop the notebook, when you restart it, they will no longer be running, and then you have to restart them as required. In terms of scaling, both offer the same scaling semantics, which is a KPU, or Kinesis Processing Unit, which equates to 1 CPU and 4 gigabytes of memory. So you can scale in and out the number of task managers running your job by modifying the number of KPUs. So that was a high-level overview of the use case differences. Before I look under the hood, I'd like to ask Stefan if there are any questions or whether you want to...
No, like I recovered my notebook, so I prepped too much. So I deleted all my notebooks I used previously, and they piled up in the trash. So like I reached a limit on the number of notebooks I can run. So now all is good. Thanks a lot, and I'll share my screen again.
Okay.
So, no, this is the wrong screen. There you go. Okay, so apologize for the hiccup, but now I'm running, I have my notebook running and responding. So what I'm going to show in this demo is how you can interactively query your streaming data. And for this purpose, I have like a Kinesis data stream, which is a replayable ordered log similar to a Kafka topic. And I'm ingesting yellow cap data into my Kinesis data stream. I'll start off with discovering the schema and then running some aggregation queries on top of that. And eventually, I want to determine interesting pickup locations. So I want to find the most busy pickup locations. And for that, I'm not only relying on the yellow cap data set, but I'm also joining with the for-hire vehicle data sets, which contains information from like Uber and Lyft so that I have a full picture. So I start with the Kinesis stream, then I join it with a Kafka topic. And last but not least, I'm going to enrich my streaming data by making a lookup to a static data set in S3. Right. So this is from a very high level what's going to happen, and I'll explain more details when we go along. So I'll start off with creating a stream or a table in my notebook, and this table basically is connecting to Kinesis, more precisely to a stream called yellow trips, and I'm already populating the trips in that stream. And for now, I don't know too much about the format of the stream, so I'm using the raw format to just get the messages, the raw messages, back from the stream. So the service will just read out all the messages from the stream and echo it out on standard out. So with that, I have created the table. There are a couple of other options. If you ever queried a Kinesis stream, those should look familiar, but I'm not going to go into the details what they mean for the purpose of this demo. So now I can just start exploring the data. So I can do select star from Kinesis yellow trips. And I'm just interested in the first few events to get an idea of how this looks like. This now under the hood spawns a Flink job that is deployed to a Flink cluster that has provisioned alongside the notebook environment. So this is not a local Kafka, not a local containerized setup. I'm running a Flink application on a Flink cluster that has been deployed on AWS when spinning up the notebook. And as you can see, we get lucky in this case. So this is just the raw data from the stream, but it's in JSON format, so we can get a feeling of what's actually in the stream. So we are in a scenario where we're talking about taxi data, and we have things like pickup times and drop-off times. We also have location, pickup location, and drop-off locations, the number of passengers, and other things like the revenue generated by the trip that are associated with taxi trips. So with that, I can actually start and create a proper schema for my stream. But before we do that, I just want to give you an impression of how much data there is in the stream, and just do a quick count and to see how many data can be read from the stream by the application. So I'll do a simple count. Over the table, yellow kinesis, yellow trips. To get an idea of how busy the stream is and how many data is arriving. As you will see, I'm already writing into the stream, and I'm using event time to fetch from the stream. So it's quite a busy stream in terms of throughput that the application can read. So again, this deploys to the Flink cluster, and in a couple of moments, we should see that we're actually reading data. And from the moment the query has been created, we've already read like close to 200,000 events. So it is a busy stream, and we're deploying this to an actual cluster and not running this locally. Cool. So with that, I can create a proper table with a proper schema. So essentially, this is very similar to the query you saw before. I'm just using the format JSON this time, because now we know it's JSON data, and I'm using attributes with proper types. I've also defined a watermark on the pickup date time. So now we can run queries according to event time. And that's important, like in subsequent queries, when I'm querying for an hour of data, the application can read much faster than the data that is produced in real time. So let's try to understand, like, let's run a simple query to try to understand like how much revenue we are generating over 1 hour windows, let's say. So with that, I'll use a tumbling window to partition the time into fixed like 1 hour intervals, and then count or sum the revenue that is generated by all trips in that interval. So I'll start with the tumbling window. So I read from my Kinesis yellow trips table. So pickup date time is my row time attribute. So I'll use that to query the stream according to event time. And I'll use 1 hour windows. Okay, so now I have my time window. I can group by the window. And then just aggregate the revenue in that time window. So I'll do a select, and some no, total amount, apologies. Okay, so this again is executed as a job on the Flink cluster, and we are basically just summing up the revenue over 1 hour interval. So once this is running, we should see the results flowing in. So the Flink job has started, and in a moment we should see the first results coming in from this query. And one nice option of the notebook experience is that we can now choose different visualizations for the data. So this is just a tabular representation, but we can also like use a line chart to see the data in a more visual way. And as we would expect, like the query, there are different times during the day where trips are busy or taxis are busy, and other times of the day where there's less traffic. So after midnight on New Year's Eve, there's a huge spike, but then these regular traffic patterns start to emerge from the incoming data. Cool. So now we have like a rough understanding of how much revenue the yellow trips are making, but we'd like to understand like what are the most popular pickup locations. And for that, I not only want to use the yellow trip information, but also the for hire vehicles, which are basically Uber and Lyft, to get a better picture of where are busy locations. And for that, I'm going to start to query a Kafka topic that contains that information. So right now we are looking at yellow cab data, and I'm now going to pull in data sitting in a Kafka topic and basically join those streams or union those streams to get a more complete picture of what's going on. So I've already created a table, and I'll just show you the schema. So this is the schema of the events in the Kafka topic, and it's similar but less rich. So it's also talking about pickup date time and drop-off date time and pickup locations and drop-off locations, but it doesn't have any revenue information, for instance, associated with it. So when I union the streams, I need to choose those attributes that are common between both streams. But what I want to highlight is like this information is pulled in from a central data catalog called Glue, AWS Glue Data Catalog, and which is just a Hive compatible meta store. And that's a great way how you can share this schema information across your organization, right? So when I created the notebook, I hooked it up with the Glue Data Catalog, and then I can create tables, and those tables are persisted in Glue so that others can discover the schema information and don't need to create the schema from scratch from there. Cool. So now that I have the Kafka table, I can create a view that basically just is the union of both streams, the Kinesis stream and the Kafka topic. So I'll create a temporary view. Oops. All trips. And I'll just do a union of both streams. So select pickup date time and pickup location ID. Kafka. And I do a union all with the Kinesis stream. So I'll just repeat that and use the yellow trips table.
We have a question about the Glue tables.
Right.
I can't respond on the chat, so I thought I'd ask it out loud. So the table is, are the Glue tables for storing metadata and not the streaming data itself?
Exactly, right. So that the Glue tables, and I can show it in a second. Just let me navigate over to AWS Glue. So this is basically metadata. It contains the schema information, other details like other meta information, how to connect to a stream, and how to authenticate, for instance, right? So this is how the table looks like, and you have like, this is again integrated with the identity and access management permission system, so you can grant other AWS users in your account access to this table, and it basically then gives access to the metadata of your table. So in the case of the Kafka table, we have like information about the Bootstrap servers, how to connect to the cluster. We also have some information on the authentication method. And here we're using IAM, Identity and Access Management. So this is quite interesting because you can use the same mechanism that you use to log in into your AWS account to sign requests against your Amazon MSK managed streaming for Kafka cluster. So instead of using fixed credentials, username, password with Zuzzle Scram or like certificates, you can use IAM authentication and then use temporary credentials to authenticate your calls against your Kafka cluster. So that's quite interesting. And that's what I'm using for this demo, actually. I have given the notebook permissions to read from specific Kafka topics. And under the hood, the Kafka table will then sign requests with temporary credentials exposed through the notebook and authenticate in this way against the Kafka cluster. So it's not a world open, anyone can read cluster, but it's only persons who are authenticated with valid IAM credentials can actually consume from the cluster. Does that make sense and answer the question?
Yeah, and if we get onto my demo later, I'll cover Glue in a bit more detail.
Mm-hmm. Perfect, cool. So we now have like a view with all trips, and we can now go ahead and group by pickup location to determine which is the most interesting or most busy pickup location. There's just one more annoying thing, and that is it's just an ID, right? So if we go back to the raw data, the pickup location ID, it's really just an int. And that's like great if systems are talking with each other, but we want to understand the data. So what I'll first do is I'll join a static data set from S3, which is basically provides a lookup table. And I'll join it with my all views table. Oops, apologies, with my all views table, so that we have like a zone that we can actually understand because it has a name and it's not an ID. And for that, let me quickly show the schema of the lookup table. So it's S3 zone lookup. And as you can see, so this is again information that is stored in the catalog, and it's again only storing metadata. The actual data sits on S3, and it basically provides like a lookup between like IDs and zone names, for instance. So I'll join that with my all trips stream. So I'll do select star from all trips T, and I'll join it with S3 zone lookup. And as this lookup table is static, I basically force the timestamp of the lookup table to be equivalent of the to the event that is it tries to join. So I'll basically say something like for system time as of t pickup and use Z as the name. So again, this just forces that like the queue can evaluate without like without needing to wait for any windows to close. I'll join on pickup location ID and just the zone ID. And to make it a bit less awkward, I create another temporary view so that I can reuse this query in my last and final query. So create temporary view all trips with zone. And that didn't work because
we have a question. Is the S3 location driven by Athena?
No, it's not. So this is just a raw table or raw object that is sitting on S3. So while this query executes, we can take a look at that as well. So it would potentially be possible if you had a more complex query to use the SQL connector to connect to Athena, run some aggregations on your static data set and then pull that in, but you can do the same thing with Flink natively. So in that case, I'm just pointing to a location on S3. So it's a CSV file. I pull that file in and read it on the fly, right? So with S3, with these tables on S3, I think it makes the most sense of it as just, again, it's metadata, and the job then pulls in the data and runs the transformation you're asking it to run. So there's no Athena involved. I'm directly consuming the data from S3. Cool. So in the meantime, I have created my view. So now I can start formulating my query to aggregate by pickup location. So I'll do something like I'll use another tumbling window. So I'll use the all trips zone table. Again, I'm using datetime as the row time. So and I'll group by 1 hour in windows. And this time, I not only group by the window itself, but also by the pickup location so that I can determine the count by location. So I'll do a group by and zone. And then I select basically the zone and the number of trips that originated in this zone. So unless I screw this up, this should now give me like a nice overview of like the most popular locations. So the query at least compiled successfully and is now deployed on the Flink cluster. And once we have the first results, we can again change the visualization to something that makes more sense in our context. Right now, we are looking at the table representation. And once we have results, we can use, for instance, a bar chart to spot the most busy locations. And as there were questions around like S3, I think this is a good segue to show how this looks in practice. So now I'm navigating to the Flink job. And as you can see, we have now 3 different sources, one for Kinesis, one for Kafka, and the last one down here that is already finished is the source reading data off of S3. It's all then coming together in this temporal join, and I'll run the aggregations afterward. So now we have results in our visualization. And if we switch to the bar chart, we can now finally see like what are popular locations. And in that case, right now in the beginning of the year, apparently like East Village is the most popular pickup location. Cool. So to quickly summarize what we have done, we started off with discovering a schema in a Kinesis stream and created a schema, ran some basic aggregations, and then we joined the data from the Kinesis stream with a Kafka topic and a static lookup table sitting on S3 to determine the most popular pickup locations over time. So I was rushing a bit through the demo, and there are lots and lots of different interesting aspects to talk about, including like scaling or authentication and how to productionize these things. So please let us know if you have any questions, and we're happy to answer them. And otherwise, I'll hand over to Danny so that he can talk a bit about the internals and how this and how we deploy the service under the hood.
Okay, thanks, Stefan. I can't see any questions, so I'll take over. Okay, thank you for the demo. I'm going to talk about the service a little bit, and then if we have time, I'll give another quick demo to show off some other integrations. So you can see here a block diagram of the Amazon Kinesis Data Analytics service. You can see in the middle, we run our job manager and task managers in containers, and these run your actual workloads. And then around this, we have a series of service components. For example, in the top right, we have auto scaling. This component is responsible for scaling in and out the number of task managers according to the demand of your job. We have a component for availability, which is used to ensure your job is running. Whether the job fails, the cluster fails, the server, or the availability zone, it will keep that job up and running. We have a monitoring component, which is monitoring the general health of your job and our service as a whole. And then we have a storage component, which is used to durably persist checkpoints and save points. So these components allow us to run your production workload so you can focus on implementing your business logic. We then have a gateway, which is used to allow you to access the Flink UI or the Flink dashboard. And the gateway applies the authentication and authorization. On the left there, you can see the services that the customer may be interested in, or you may be interested in configuring or using to get insights into your running jobs. So CloudWatch is where we will ship or Amazon CloudWatch is where we will ship your logs and metrics. And AWS Identity and Access Management is where you will configure the roles and permissions that allow the job to integrate with other services in the AWS ecosystem. So I'd like to, this is for the Apache Flink offering. So I'm now going to compare it to Studio, which is what Stefan was just demonstrating. So you can see we have added another container, which is the Apache Zeppelin container, and this runs the interactive notebook environment. The same gateway is used to communicate and give you access to that notebook environment, which is accessed via a browser, as Stefan showed. You may notice the auto-scaling component has gone. That's because it doesn't make as much sense in this scenario, since the actual workload of your task manager varies drastically throughout the day as developers start and stop jobs. We leave it up to the customer to specify in advance how many KPUs or Kinesis processing units they would like for that particular instance. And finally, the storage component is now also persisting your actual notebook code, which is different from the Flink offering. Okay. So on the left-hand side, you can see we've added another integration that customers may be interested in configuring. This is the AWS Glue Data Catalog, as Stefan showed. This is where we store your databases and tables, which allow you to integrate with the SQL abstraction and share them tables across your organization. Okay, so if there are no questions, I'm going to move on to my demo, and we've only got a few minutes, so I'll try and go through it quite rapidly. So what I want to do is implement a very, very simple ETL or extract, transform, load query. So we're going to take a very simple schema, which is a user, which has an ID, a first name, and a last name, and we're going to transform that to a person or a people, which basically is going to concatenate the first and last name. So it's very simple, but it will show off the integrations that we've mentioned. So we're going to use the Glue Data Catalog abstraction layer to read from a Kinesis stream, transform it in Studio, and then push it out to a new Kinesis stream. Okay, so to start with, I want to show you the data. So I'm using Kinesis Data Generator. This is a web-based tool that allows us to generate data. So I'm going to choose the source. The Kinesis streams have been named semantically for my job. So we have one called source and one called sync. I'm going to just stick with 100 records per second, and we're going to generate an ID, first name and last name. If I hit test, you can see the data that's going to flow through the system. So let's just start that off. So if I jump to the notebook, just to demonstrate some of the catalog integration, I'm going to invoke show tables. And you'll see we have the people table, which I've pre-created. But I'm going to go and create the users table from Glue to show you the other flow, the other way around from what Stefan was showing. So if I jump over to Glue or to the console, I'll navigate to AWS Glue. You'll see, if I jump up to databases, you'll see we've got two databases in here, one and Studio Notebook. So if I go into Studio Notebook, tables, we have the people table, which you just saw. So we're going to manually add a table. So this table is going to be called users, and it's going to be in the Studio Notebook. So the table, as we just explained earlier, the table is an abstraction layer over the actual data storage. So the data store for this table is going to be a Kinesis stream in my account, which is called source. The data is in JSON format, and I'm going to add create a simple schema that relates to the data we're generating. So we have an ID, first name, and a last name. And the ID is a big int, and then we've got two strings for the first name and last name. So I can skip this. I can hit finish. So now you can see we have, when it refreshes, you can see we've got these two tables within this database. If I go back to my notebook and rerun the show tables query, we'll see the two tables appear. And then if I describe the users table, you can see the schema we just created. So to show you the data's flowing, I'm going to run a quick, simple select query. So select star from users, and that should show us. That will run a Flink job on the Flink cluster, and it will stream the results back to the Zeppelin UI, and we should see them appearing here. There we go. So we can see the data start to flow. I'm going to just stop that job, and I'm going to select from the people, which is our sync table instead, and run that just to show you that there's no data flowing. So there's nothing flowing into the output stream at the moment. And this is where I implement my business logic. So insert into people, select concat first name space last name from users. So should this query run successfully, we should start to see that data flowing into the people table, and it should be displayed in the paragraph above. So the Flink job has now started, and here we go. We can see our transformed data. So we've now achieved our end-to-end business logic. And very quickly, we discussed earlier about when you're ready, you can ship these things to production. So we've added features to Studio to allow you to easily do this. So at the moment, I'm in a development note. Let's create a new note and just call it prod, and I'll paste in my query. We've added this dropdown and this build button. This allows us to actually compile our code and generate either a jar or an archive, which contains Java bytecode or Python code, and it will include all of the dependencies required to run your job on Kinesis Analytics. It will also tell me where I'm going to store it, so I could download this from. It goes to Amazon Simple Storage Service, so you can download the code and you could run it locally, or you could deploy it to KDA. So you can hit build as many times as you like, and then when you're happy, you deploy it. So since this takes a couple of minutes to deploy, I have an example here, which has already been built. So on this one, when I click deploy, when I click the dropdown, I now have the option to deploy this to Kinesis Data Analytics. When I click this, it will give me a dialog which explains what I'm deploying, where the code is, when it was built. And then I click deploy, and it will jump me into the console, and it will pre-populate the code for me, the name, the code, and also the database. You will need to go and configure the IAM permissions to grant access to the streams. But once you've done that, you should be able to click go, and you've now deployed your business logic to production as a running application. And I think I'm over time, so I'll hand back. Thank you.
Perfect. Thank you both for an incredible presentation. We have got a couple of questions that have come in, but unfortunately we are out of time now. We are moving on to our next set of sessions, so you can click in the sessions tab and head on over. But you can also, if you have any additional questions for Stefan or Danny, if you head to event and click people, and you can find them on the event list, and you'll be able to direct message them any questions you have as well. And I'm sure they'll be happy to help with that. Brilliant.
Thanks a lot, everyone, for joining. Thanks a lot.
Thank
Bye.
you. Bye.
Cheers.
Thank you. Bye.